Let's say you have this problem description where you have a car factory and there are multiple sections in this factory. Each section assembles one type of car. You create two types of cars as of right now, but it could be more, Ford and Mazda. You need to create code to assemble the correct engine for each car. If your systems can't recognize the car type that you have, just don't assemble the engine. So if somebody says, hey, build me a Toyota engine, you're just gonna say, oh, I don't know anything about Toyota. Error. In procedural world, you might have to use if statements to check what type of car you're making in that section of the factory. In OOP world, you might have a car class with Ford and Mazda extending it and calling assemble engine, which is implemented differently for each type of car. Here's your common inheritance pattern. Now remember that type classes provide a way to do this ad hoc inheritance without dirtying the interface and without having to change the source code. And with this in mind, let's write some code. So first, we're going to define a trait car. It should be a sealed trait, but this works for now. And then we're going to have two case objects, Mazda and Ford, extending this car. And we're going to define type class members on Mazda and on Ford. So let's see that. We're going to start with an interface, which each type member will have to implement. At the top is the error to show when the type member is not implemented. So if you try to call this with a different type of car than the one that we recognize, it will give you this error, no type member of class car finder in scope 4, and then it will tell you whatever type that you passed in. So as you can see, this interface has a type member A and a method called assemble engine. Here are two type member implementations for Mazda and Ford. You need to add the word type after Ford and Mazda because Mazda and Ford are objects. So this means they are in-memory objects. So in order to get their actual type, you need to do dot type. Now classes, on the other hand, are not automatically in-memory objects until we use the new keyword on them. So for a case class, we would not need to add the dot type here. And here is the method callers need to use, which will automatically find the correct type class member to use on type B. So let's go through the signature. Assemble engine takes a type parameter B, which is bounded by car. This means whatever B you use to call this method with, it must extend car. In this case, we have Mazda and Ford as acceptable types for B. I copied the last method from the previous slide to the top here so we can see it better. So let's go through it. Say you call method assemble engine with Mazda and some message, doesn't matter what. What happens is the implicit will try to find a car finder with a type member Mazda, and on that call method assemble engine. So later on we will see that we can simplify this method signature a little bit by using syntactic sugar.